Hello geometry students, my name is Emigh, and this video is our discussion on chapter 9, right triangles and trigonometry. We'll cover two sections, 9.1 and 9.2. Title of section 9.1, the Pythagorean Theorem and its converse. The Pythagorean Theorem says that if triangle ABC is a right triangle, then the length of one of its legs squared plus the length of its other leg squared is equal to the length of the hypotenuse squared. If we're using capital A, B, and C to represent the vertices in that triangle, then use lowercase a to represent the side length of the side opposite capital A, lowercase b to represent the length of the side opposite capital B, and lowercase c to represent the length of the side opposite capital C, which we want to be the hypotenuse in this case. And then we can rewrite that equation in terms of lowercase a, b, and c as a squared plus b squared equals c squared. And just make sure that you're summing the lowercase a and b, and c is after the equal sign because it is the hypotenuse. All right. We have what are called Pythagorean triples, and that is when we have a triangle that is a right triangle and all of its side lengths are positive integers or whole numbers, if you want to think about it like that. So some examples of a Pythagorean triple would be the 3, 4, 5, the 5, 12, 13, the 8, 15, 17, the 7, 24, 25. Now let me show you how the 3, 4, 5, for example, satisfies the equation a squared plus b squared equals c squared. So we would set that up as 3 squared plus 4 squared is equal to 5 squared. And by satisfies that equation, it means we have balance. The left side is equal to the right side. So let's just check that. That would be 9 plus 16 equals 25, which means 25 equals 25. Okay, so you can see there that the equation is satisfied, making the 3, 4, 5 triangle a Pythagorean triple because 3, 4, and 5 are all whole numbers. All right. I also want to point out that any multiple of the 3, 4, 5 is also a Pythagorean triple. For example, the 3, 4, 5 we know is a Pythagorean triple we just saw. But if you do the second multiple, that would be 6, 8, and 10. That's a Pythagorean triple. If you do the 10th multiple, it would be the 30, 40, 50. That's a Pythagorean triple. And these will be useful for you to memorize, especially the 3, 4, 5, the 5, 12, 13, just the ones I have listed here and any of their multiples. Because if you do see a right triangle that has, let's say, 3 and 4 as its side lengths, you won't need to take the time to calculate the length of the hypotenuse. You would know it's 5. Or another example would be if you knew a right triangle had a hypotenuse of 5 and one side length of 3, you would know that the other side length is 4 because of the Pythagorean triple 3, 4, 5. So it can just save you time and save you from making any small mistakes by doing the calculations of the equation on your own. So they can be helpful in that way, the Pythagorean triples. If you don't memorize them, then you can use the formula to find any missing pieces. Okay, so let's look at this one. We're asked to find the length of the hypotenuse of triangle ABC. And we're asked to check to see that the side length of triangle ABC form a Pythagorean triple. Okay, so we're going to call this third side here lowercase c or question mark if you want. And then we're going to set this equation up as 20 squared plus 21, plus, let's see why this is not happy right now, plus 21 squared. We're going to check if that is equal to c squared, and if c is a whole number, then we would have a Pythagorean triple. Let me see if I have this typed out because my writing is not looking very nice right now. Okay, so it turns out when we solve that equation for c, we get 29. I'll go ahead and show you that work then. 20 squared plus 21 squared equals c squared. That would be 400 squared plus, grab my calculator here, 21 squared is 441 is equal to c squared. I need to erase that the squared on the 400. Once I squared that 20 squared is equivalent to 400, not 400 squared. Now we'll do the sum. That is 841 is equal to c squared. Now we'll take the square root of each side of the equal sign. We're only going to use the positive root because we are talking about side lengths. So using my calculator, because I don't have it memorized, the square root of 841 is 29. So we have c equals 29. Okay, so that's where that 29 came from. And we do have all three side lengths being whole numbers or integers, 20, 21, and 29. So it turns out that we do have a Pythagorean triple here. It's the 20, 21, 29. All right, so now I'm going to erase my work and show it typed up. Let's see, we'll erase all that. And here it is. The length of the hypotenuse is 29. 20, 21, and 29 form a Pythagorean triple because they are positive integers that satisfy a squared plus b squared equals c squared. Okay, find the length of the hypotenuse. So in this equation, finding the length of the hypotenuse. Well, in this triangle, we were given the length of the hypotenuse. So we're going to use it to find the value of x. And in this triangle, x is representing one of the lengths of the legs. And we're asked to write our answer in simplest radical form. All right, so let's set this up. We have one leg squared plus the other leg squared equals the hypotenuse squared. 8 squared is 64, 20 squared is 400. Subtracting 64 from both sides, we have x squared is equal to 336. Taking the square root of both sides, only the positive root in this case, we have x equals the square root of 336. Now 336, if you type it into your calculator, so second square root 336, it's about 18.33, so like 18 and a third, which is not a whole number. It's an irrational number that goes on, and we have our directions that say to answer in the simplest radical form. So because it says that in the directions, we don't want to give an answer of like approximately 18.33. Now, if the directions had said, give your answer approximate to the nearest hundredth, then you could go with 18.33. But since they say to write our answer in simplest radical form, we can't go into that decimal form. No approximations here. So it turns out that 336, even though it's not a perfect square, it has a perfect square as one of its factors. That perfect square is 16. 16 times 21 is 336. And this one is gonna help us reduce this radical because 16 is a perfect square. It's a 4 by 4. So if we take the square root of 16, we get regular old 4. And the square root of 21 is, well, that would be another decimal. Let's see what it is in our calculator. Square root of 21 is approximately 4.58. And so we wouldn't want to take that to decimal form. 21 does not have another perfect square factor that we could take out, so we would just leave it as the square root of 21. Okay, so all of that means that our square root of 336 reduces to 4 times the square root of 21, which is the simplest radical form. All right, a 50-foot supporting wire is to be attached to a 75-foot antenna. Because of surrounding buildings, sidewalks, roadways, the wire has to be anchored exactly feet from the base of the antenna. Okay, so let's pretend this is your job. You've got this huge antenna here and this huge wire, and you've found this place on the ground that's, I'm assuming, a safe place, considering the buildings and sidewalks and roadways. And this place that you have found on the ground is 20 feet from the base of your antenna, okay? So here you are, standing right there. you know you've got to a 50-foot wire that you've got to then climb this antenna and support that wire on the antenna. Okay, so our question is, how high from the base of the antenna must the wire be attached? So we know our antenna is 75 feet tall. So we need to get a ladder or a crane or whatever it is we're using to get up the antenna and mount the wire. So how high from the base of the antenna must the wire be attached? And we're asked to give that answer as an exact answer and in an approximate 1 decimal place approximation form. All right, so we can use the knowledge that the ground and the antenna form perpendicular lines or a 90-degree angle, giving us a right triangle. We know the hypotenuse has to be that 50-foot wire. We know one of the legs has to be that 20 feet. And so before attempting to climb this antenna, we can do some math and figure out how high it is we have to climb. So we can set this up as 20 squared plus x squared equals 50 squared. Do our exponents there, subtraction property of equality there, square root both sides there. 2,100 is not a perfect square, but it can be broken down into 121. That is a useful breakdown for us, that factor, because 100 is a perfect square. It is a 10 by 10. So the square root of 2100 is 10 radical 21, and that is approximately 45.8 feet. So very useful information before climbing that ladder or crane with that heavy wire. For safety purposes, we use our math skills, and we know that we need to go vertically 54.8 feet to attach that wire to that antenna. Okay, the converse of the Pythagorean theorem is also true. So remember, the Pythagorean theorem stated if triangle ABC is a right triangle, then a squared plus b squared equals c squared. Well, the converse is true as well. So if a squared plus b squared equals c squared, then triangle ABC is a right triangle. All right, so using that fact, or that converse of that theorem, we would know that if a squared plus b squared is greater than c squared, then we don't have a right triangle. If a squared plus b squared opens wider, okay, gives us a being less than c squared, then we have a triangle that is obtuse. Similarly, if a squared plus b squared opens less, I'm talking about like the hinge, this part opens wider, this part opens less, then a squared plus b squared would be greater than c squared, giving us an acute triangle. It's a little counterintuitive if you first look at it, because you see the is less than, but it's obtuse, versus if it's greater than, it's acute. Intuitively, you might think, oh, if it's less than, it's acute, greater than obtuse. But if you think about the surface area, here we have a squared, here we have b squared, and then c squared would look like that. So the two smaller rectangles, squares, 1 and 2, would have to fit into the largest square, 3. I'm going to show you the same thing down below with the obtuse and acute triangle. Let me just erase some of the scratch work first. So if this hinge right here opens wider, then the square off of A and the square off of B become larger, and the square off of C is actually not as large. So it is, it is greater than the squares off of A and B. Hope that didn't confuse you more. Let's do it one more time. This one's a little easier to see because I couldn't do my full squares on that obtuse triangle. If the hinge right here at C is opened less, then we have that square of A and that B squared, And notice how C, that hypotenuse, has shrunk. So that square created from C squared is smaller now. So that would make A squared and B squared greater than C squared. Okay, so ultimately, if they are equal, it's a right triangle. If it's less than, obtuse. And if it's greater than, acute. All right, so let's classify this triangle. A triangle has the given side lengths, and they are 6, 11, and 14. And then we're asked, is that triangle going to be acute, obtuse, or right? So if we set it up as 6 squared plus 11 squared, and we're questioning, let's write a question mark there instead. 6 squared plus 11 squared is question mark to 14 squared. So that would be 36 plus 121 is question mark to 196. Check my work on that. Okay, so 121 plus 36. So we end up with 157 being question mark to 196. And 157 is less than 196. So we have an obtuse triangle. So if you had these three side lengths, you form a triangle, you'll end up with an obtuse triangle. Pause this video and try B. Welcome back. If you ended up with 7,225 is equal to 7,225, you got it right. That makes it a right triangle. If you didn't end up with that, you might have set it up in the wrong order. You have to be careful to make this one the hypotenuse. So you want to set it up as 13 squared plus 84 squared is question mark to 85 squared. You may have put them in a different order, like 85 squared plus 84 squared is question mark to 13 squared, because that was the order they gave them to us. But you have to remember to do the smaller sides summed is compared to the largest side. All right, pause the video again and try 12, 17, 14, being careful to make 17 the hypotenuse. If you ended up with 340 is greater than 289, you got that right. That would come from 12 squared plus 14 squared equals 12 squared. And that would make that triangle an acute triangle. Okay, that video ended up being a little bit longer than I thought, so I'm going to go ahead and stop after just section 9.1, and I'll cover the next, we can discuss section 9.2 in a separate video. My name is Jamie Emigh. Thank you for joining me, and see you next time.